Hello everyone and welcome to another video. So it's winter, it's exceedingly cold outside and it gets dark at around 4 o'clock. So I'm going to be doing quite a few more indoor videos. Also apologies if the lighting isn't the greatest. As I said, it's dark and I'm doing the best that I can do with what I have available. Unfortunately, I do not have studio lighting. But never mind all that. And given the circumstances, I figured it would be a very good time to do another episode in the Mining Molybdenum series. Now, recap for those of you who haven't watched the first one, it didn't go so well, and there's a very good reason why it didn't. The reason is that the ore that I had was a lot more like these rocks than the sand that I was expecting. The ore sources I had investigated prior were mostly silicon dioxide, whereas the one I had for the video I thought would be higher in molybdenum, and it was because it was closer to the source. However, it was also much higher in calcium carbonate, which I needed to get rid of. And all that means that the ore source that I had, and still have, can't be refined economically in the way that I wanted to. So unfortunately, it looks like I'm going to have to do a bit more science than I wanted to, but I'm sure we'll be able to make it work. So I'm going to demonstrate this with a diagram because it's a lot easier to keep track. And this is the ore source that we have. It's high in calcium carbonate, low in silicon dioxide relative to ores that I've processed prior. And it is also higher in molybdenum as being closer to the source, but I can't acid wash this as the first step. There's too much calcium carbonate. It'll react with all the acid and use it all up. Now, one option I have is to simply get rid of the ore I have and just switch to a new ore source that is lower in calcium carbonate. The problem with this is that it's likely going to be lower in molybdenum, and it really restricts what ore I can use. I mean, ideally, I'd like to be able to refine these full rocks. But if I cop out and just change to a different ore source, I'm really limiting my options for source material. So I've looked more into the chemistry of all this and how it's produced industrially, and I figured I have about 2 options, each with different subcategories that I'll get into, as to how I can process this ore right here. I can either try to enrich it, or I can say I don't care about this and just roast it anyway. So let me explain the difficulties of roasting it outright. Either I control the temperature, molybdenum disulfide will turn into molybdenum oxide at a lower temperature, and calcium carbonate will turn into calcium oxide. So if I can control the temp, and granted it's a pretty big window, around 400 degrees Fahrenheit, but I still have to be able to control the temperature. I essentially need a more specialized setup to do this, which I might need anyway. I'll get to that in a bit. The difficulty is that if I can't control it, the calcium oxide turns into calcium hydroxide in water, and the molybdenum oxide turns into molybdic acid in water, and adding water is a necessary refining step. Now, calcium hydroxide is a base and molybdic acid is an acid. So anyone who knows somewhat about chemistry will understand that there's a problem with that. The 2 substances will react to form this mineral here, powellite, which is insoluble. Now, what I could do is say, this is not a problem. All I have to do is remove the excess calcium hydroxide that forms by dissolving or suspending it in water. I'm not entirely sure how that's going to work. I haven't tried it yet. But essentially remove all the excess calcium until you just have this powellite associated with the insoluble sands and other materials. Then add some hydrochloric acid, which I have on hand anyway, to remove the molybdic acid from the calcium molybdate, thus making calcium chloride and molybdic acid. The molybdic acid could then be refined through recrystallization. Now, recrystallization is not an easy process, and I don't think my chemistry aptitude is really good enough to get really high yields. And that's just being realistic. Recrystallization is a very difficult process. Now, I could also try to enrich the ore, and they do this in industry in a process called froth flotation. They use a bubbler system to sort of catch the molybdenum disulfide, which is a non-polar substance, so it really doesn't like water all that much. It's just heavy, so it sinks. But if you can float it on bubbles, then for some reason it will rise to the top. I'm not entirely certain on how I would manage this, which is also why I'm not too keen on doing it. It would probably need a specialized setup, and I don't even know if I could make it work. But I might be able to make it work with a more low-tech setup by using the same principle. Oil is non-polar, and maybe if I grind the ore up in, like, say, a mortar and pestle, and get the molybdenum disulfide suspended in the oil, perhaps I can refine it that way. Now, I have yet to do any tests, but I'm leaving all 4 of these options on the table. This option, nah. As I said, I do want to be able to refine stuff like this one day. So this is out. But all these 4 options are on the table. Now, as far as a long-term solution is concerned, I'm thinking this one might be really good, because I'm going to need a specialized setup anyway for one very lucrative reason. And that is the fact that molybdenum disulfide ores tend to contain a very small rhenium impurity, which, if you can catch the flue gas that comes off of the roasting, you can collect that rhenium, drop it out through recrystallization, which isn't as much of a problem because rhenium, even if I were to obtain the smallest, tiniest amount, it would be worth my time. Rhenium is a very rare and expensive element, and as far as I know, this process is basically the only way it can be obtained from natural materials. Most rhenium is recycled. It's used in fighter jets and all manner of very high-tech, high-expense equipment. Now, I don't know how much rhenium impurity is in here. It's not going to be much either way. I think like either in the thousandths or hundredths, but it's enough to certainly investigate and build an apparatus capable of capturing it. Now, unfortunately, I don't have any data on how much rhenium is in these ores because it just doesn't exist as far as I know. The mines in this area, most notably the Edison mine, closed down in the early 20th century, and rhenium was one of the last elements to be discovered. They closed down before the element was even discovered, so you're not really going to have any data on how much is actually in here. There's likely not going to be much, but you never know. Now, all 4 of these options are 100% on the table. In fact, I'm going to try all 4 of them if I can manage. This one might be a little difficult, but I'll give it a shot if I can manage to make it work. And stay tuned for those. They're probably going to be episode 3, 4, 5, 6, in really no particular order. I'll probably try the oil first, but we'll have to see. Anyway, hope you guys enjoyed. Hope you guys stay tuned for more. See ya.